All right, let's try another example of taking a derivative of a parametric equation. So parametric equations look like this. You got x is a function of t, y is a function of t, and t is in some range of values. The derivative of a parametric equation looks like it behaves as a fraction. It looks like dy dx can be found by just canceling out the dt's, but really we know that this is the derivative of y divided by the derivative of x. Here's an example. Where does the function, the parametric equations, x equals 2 cosine t, y equals t squared plus 4t, and I'm going to say t could be any real number whatsoever. So where does the graph of this parametric equation have a vertical or horizontal tangent line? Okay, well, we've seen in Calculus 1 that there's a horizontal tangent line in your function when the derivative is equal to 0. The slope is flat. So in this example, I'm going to start by taking the derivative. So the derivative, dy dx, is dy dt. So the derivative of y would be 2t plus 4, divided by dx dt, which I guess would be negative 2 sine t. So there's my derivative. And I know I get a horizontal tangent line. Let's do horizontal first. I get a horizontal tangent line when this derivative is equal to 0. Now, the only way a derivative of a fraction can be 0 is if the top is equal to 0. So I need 2t plus 4 to equal 0. That, of course, tells me t is negative 2. So the t value that I have a horizontal tangent line is negative 2. The xy coordinate I could find by plugging in negative 2 for t. So the actual xy coordinate would be 2 cosine of negative 2 radians, whatever number that is, times negative 2 squared plus 4 times negative 2. So there's the xy coordinate where I have horizontal tangent lines. Now let's do vertical. We didn't really find functions that have vertical tangent lines in our calculus past because in previous calculus courses, we were primarily dealing with functions of one variable. And functions of one variable have to pass the vertical line test, meaning there usually aren't any vertical tangent lines. So, to find where we have a vertical tangent line, I need to know where this derivative is undefined. I need to know where this derivative has an arbitrarily steep tangent line. That's where the bottom is equal to 0. That's when I'm kind of dividing by 0 and I get an arbitrarily large slope. The tangent line's going up. So to find the vertical tangent lines, I'm going to set negative 2 sine t equaling 0. Solving this equation, sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0. So actually, I think I get any multiple of pi equaling 0. This is where k can be a whole number, so like negative 2, negative 1, 0, 1, 2, and so on. So those are the t values. What are the actual xy coordinates where I get vertical tangent lines? Well, I just plug in these values for t, and I get 2 cosine an integer multiple of pi. And then I get k pi squared plus 4 times k pi. K here could be any whole number. So in our next video, I will plot this parametric equation to show you what things are actually looking like. All right, see you there.